Let's use this next example to discuss the differences when we're at the top of a circle as opposed to the bottom of the circle. In this question, we have a 285 gram mass on the end of a 26 centimeter long string. It is spun vertically at a speed of 4.97 meters per second. We want to determine what is the tension on the string. We're going to compare how that tension is at the top of the circle as opposed to the bottom of the circle. What we know, regardless of whether we're at the top or the bottom of the circle, we are going to have a mass of 0.285 kilograms. That's given in the question. We're also given the string's length, or the radius, of 0.26 meters, a velocity or speed of 4.97 meters per second, and our goal in both of these problems is to solve what is the tension. So let's look at part A first. In part A, we are at the top of the circle. So when we're there, I'm going to draw a free body diagram. Our object is now at the top of the circle, and as always, the force due to gravity is going to act down. We also know the tension force for the rope is going to be straight there, straight down as well. So in this case, because both lines are going down, I'm going to make down positive and up negative. That way I'm just working with positive numbers. Remember, our centripetal force is our net force when we are moving in circular motion. So we're going to have our tension force plus our force due to gravity are our two forces acting on the object. We want to solve for the force of tension, so we're going to rearrange for tension. Tension is equal to centripetal force minus the force due to gravity. Now, let's plug in our formulas for these two forces. So tension is equal to our centripetal force is mv squared over r. The reason I chose to use that formula is because we're given m, we're given v, and we're given r. This is going to be minus our force due to gravity, which is mass times the acceleration due to gravity, which again, we have mass, and acceleration due to gravity is going to be constant. So if we now plug in, we can solve. Our mass, 0.285 kilograms. Our velocity, 4.97 meters per second squared, divided by the radius, 0.26 meters, minus our force due to gravity, which is our mass, 0.285 kilograms, times your acceleration due to gravity, 9.81 meters per second squared. Again, these are positive because in my diagram I made down positive. So if you're solving this, I recommend you do it one step at a time. I would solve this term first, which is 27.08 newtons, minus the second term, which is 2.80 newtons. So your tension force at the top of the circle is going to be 24 newtons, and it's positive, so it's going to be down. So that is when you're at the top of the circle. So in part B, we want to solve when we're at the bottom of the circle. So for part B, I'll draw another free body diagram, this time at the bottom of the circle. Our object is going to have our tension force from our rope acting up. Right? Our rope is going to be at the center in the radius, or at the axis. Our force due to gravity, as always, acts down. This time I'm going to change it up. To not confuse myself, I'm going to make up positive and down negative. So we are going to again have our centripetal force is our net force, and all of the forces acting on it are going to give us our centripetal force. So we're going to have the force due to tension plus the force due to gravity. We're wanting to solve for tension, so we'll rearrange. Tension is equal to centripetal force minus the force due to gravity. Now that you're here, you can go back and you can do all of these steps again, but we already found the centripetal force is 27.08 newtons, and we found the force due to gravity is 2.80 newtons. So the only thing we're going to have to change is what one is going to be positive and which one's going to be negative based on their direction. So your centripetal force is equal to 27.08 newtons. We know centripetal force acts towards the center. So in this case, it's going to be up. We're going to have a positive number. We're going to subtract this from the force due to gravity, which we found was 2.80 newtons. However, the force due to gravity is acting down, so we need to make sure that it is negative. When you solve, your tension is going to be 30 newtons, and your answer is positive, so it's going to act up. So when you're at the top of the circle, you're going to have a tension of 24 newtons down. When you're at the bottom of the circle, you're going to have a tension of 30 newtons up. The last thing that we can use this topic to solve for is minimum speed. This question wants us to determine the minimum speed of the cars on a roller coaster with a radius of 42.6 meters that can move in order to just make it through the loop at the top. So we're going to be at the top of our loop. So if we're drawing our free body diagram, we're going to have our force due to gravity acting down. Alright, that is our only force acting on the roller coaster right now, the minimum speed. So what does it have to do so it's not going to fall down? Because of that, we're going to assume that the normal force is equal to 0 and that the tension force is equal to 0. Whenever you're solving for minimum speed, your normal force and your tension are 0. So, as always, we need to decide which way we want to make positive and which way we want to make negative. Because the only thing we have is acting down, I'm going to make down positive and up negative. From here, it's pretty straightforward to everything we've been doing. The centripetal force is your net force, and the forces acting on it are just the force due to gravity. Again, because your normal force is going to be 0 and your tension force is going to be 0. So for centripetal force, you have mv squared over r, and for your force due to gravity, you have mass times the acceleration due to gravity. Masses cancel out because it's on both sides, or it's on both terms, and we are left with v squared over r is equal to the acceleration due to gravity. When we rearrange for the speed, we are solving the square root of the radius times the acceleration due to gravity. Since we have that information, we're going to plug in our radius of 42.6 meters and the acceleration due to gravity, 9.81 meters per second squared. Don't forget to take the square root. When you plug in and solve, your speed is going to be 20.4 meters per second.